Okay, welcome back to another video lecture for Math 1316, Plane Trigonometry. And in this video lecture, we're covering section 2.3, which is a very, very short section because it has to do with using technology like a TI calculator in order to approximate the values of trig functions. Now, the way that the TI calculator actually achieves a trig function is not the same exact way that we would do it. So we can make drawings and find the ratios of the sides to exact measurements, and the calculator does this, and if I remember correctly, the calculator actually uses something like a Taylor series in order to find these values, or maybe it has like a library of these things that were calculated by hand. I'm not entirely sure, but the calculator is good for approximating trig ratios that are not on our list of special angles that we use all the time. So the special angles that get used all the time are 0, 30, 45, 60, and 90 degrees. And then any angle that can be formed that has a reference angle of 30, 45, or 60 degrees. Those are very, very common things that we see in trigonometry, and so of course we know that those are like 1/2 square root 3 over 2 or square root 2 over 2. Now, on a calculator, we can do all sorts of really crazy stuff. So, to begin with, this particular section will give you all sorts of measurements that are frankly not nice. So for example, one of the suggested problems in the homework of this section is the tangent of 68 degrees 43 minutes. Well, okay, that's not an easy thing to just remember by hand. There's a ton of those. You're going to have to use something like a calculator in order to do that. And a lot of real world measurements are really gross like that. So most people, for practical reasons, do end up using approximations used in engineering all the time, surveying, all sorts of stuff. So what we have is a calculator that is capable of that. And the very first thing that we want to do on this type of calculator is we want to hit this mode key, and I'm going to show it to the screen here as best as I can. The mode key takes you into this menu, and you'll notice that I have an option to pick between radian and degree. So for right now and the next little bit in the trig course, we want our calculators to be in what is called degree mode. And that just tells the calculator that when we pass it an argument in one of the sine, cosine, or tangent buttons, that it is expecting that argument to be in degrees, which is just a different way of measuring an angle from the radian measures. Okay, so the good thing is with the calculator, the reason why this lesson is super short is we can quite literally just type what we see, provided that we are in the correct mode. Directly in the calculator, it'll do the work for us. So the tangent of 68 degrees 43 minutes, we can type directly in. Now the way that we get the degree symbol and the minute symbol is fairly easy. We hit the second button, and then we hit the apps key, which is usually in purple, and you'll see those three options there. It is degrees, minutes, and then we have a little r, and then we have DMS, and then we have some other options about polar coordinates at the bottom. So the degrees and minutes symbol right there at the top, degree, minutes, and we just type it, hit the clear button, exactly the way we see it. So when you hit enter, it gives us a ratio. And that's pretty much it. That is section 2.3. So we can either do degrees and minutes, in which case we have to use that second apps button in order to do those types of calculations, or we can be given an angle that has a decimal attached to it. For example, this second example is cosine of 193.662 degrees. So I can quite literally type cosine of 193.662, and then I use the degree symbol typed into the calculator exactly the way that I see it. When I hit enter, boom, there it is. That's the ratio. And the exact forms of these are usually something that is like really ugly. So the homeworks for this section 2.3 are super nice in that they allow you to use decimals. It's probably the only time you're actually ever going to be allowed to use decimals. throughout this course, other than the practical problems, which are going to be like heights of a lamp post or a shadow being cast, or the distance across a pond, or that kind of thing. Other than practical problems like that, you just round them to the whatever decimal Pearson tells you to round it to. The rest of the time we'll be using exact answers, and the angles we'll be given are much nicer because they are based off of those nice special angles that we already have begun to kind of allude need to be memorized. 1/2, square root 3 over 2, square root 2 over 2, and so on. Now, this section does introduce us to some of the 6 other trig ratios. The other 3 of the 6 trig ratios, excuse me. And so if you notice here, this is the only thing that we need to clear up very, very early on. There are only 3 buttons for trig functions on the calculator. There's a sine, there's a cosine, there's a tangent. And then if you look in the little blue writing above sine, cosine, and tangent, you'll see sine -1, cosine -1, tangent -1 power. Those are not, and this is super important, so if you are a notes person, I know that in classes I'll make a huge point of this. But if you're watching this from, say, a different course, or as just a supplement to your learning, I would write this down somewhere in your notes. Those things are not cosecant, secant, and cotangent. The way that we have to do secant, cosecant, and cotangent in the calculator is using the reciprocal identities. So for example, if you want the cosecant of something, the reciprocal identity says that cosecant is 1 over sine. Okay? Similarly, if I wanted a secant, I would have to type 1 over cosine. And if I wanted a cotangent, then I would have to type 1 over tangent. I put a little plus on there by accident. I guess I hit a key that wasn't supposed to be hit. But we have to have at least those reciprocal identities memorized, because the calculator does not have a button or a function native to it for secant, cosecant, and cotangent. You have to use those identities. What that translates into is that if you're going to use a calculator for an approximation of something like this, you just replace, for example, in the question, if it says, and here's an example, cosecant of 35.8471 degrees. Well, then I'm going to type 1 over the sine, because that's the cosecant, of 35.8471 degrees, just like this, into the calculator. And then when I hit enter, it does the cosecant ratio for me. Okay. Now we can also do negative measurements. We have the secant of -287. And so the secant would be 1 over the cosine, -287 degrees. We type it in exactly the way we see it, and you notice it will do that ratio for us. Any calculator approximations, we can also round them. So just whatever it says to round to, please keep in mind that if you use this mode key that's available on all TI calculators, and you go down and you see these little decimal markings right here, this will tell you how many decimal places it's going to take the approximation to. So if I wanted 3 decimal places, I set it to 3, hit clear, run it again, and you see it rounds to 3 decimal places for me. So just keep in mind if you have trouble rounding for whatever reason, the calculator can kind of save you a little bit of grief on that too. Okay, so because we had to make a big distinction between the second button and sine, cosine, and tangent, what that sine -1, cosine -1, tangent -1 actually is, those are buttons that for right now, and I'm kind of going to tell you a lie here, but right now what I want everybody watching this to understand is that those buttons take a really good approximation of what angle has a cosine of a certain amount, okay, or a sine of a certain amount, or a tangent of a certain amount. So if I were to give you 0.92118541 is equal to the cosine of theta, and then I ask you what is theta, what angle had that cosine, what we can do is we can use this second, we can use this second cosine key. And you see that puts cosine -1 up here, cosine negative first power. That is going to give us an angle out of this, okay? So in sine, cosine, tangent, secant, cosecant, cotangent, we plug an angle in and it gives us a ratio out. For sine -1, cosine -1, tangent -1, or sine inverse, cosine inverse, tangent inverse, we plug a ratio in and it gives us an angle out of it, okay? So cosine of theta equal to 0.9211, I'm just going to shortcut it a little bit to make my life easier. It's 0.9212 if we round. Cosine of 0.9212, if we wanted to find an angle that had that cosine, we can use this cosine inverse key in the calculator, and you notice that it spits out something 22.898. Well, that means that if I take the cosine of 22.898 degrees, then it will have the measure 0.9212. Okay, so I can show that very quickly. Just if I take the cosine of that angle, 0.921, and I've got it fixed for 3 decimals right now, which is why it's not showing the 2 on the end, but it's 0.9212. So what those cosine, sine, tangent to the -1 power are, they are the inverses of sine, cosine, and tangent. So they take a ratio as their input and they will spit out an angle. So you'll be asked to do that a couple of times, but we're not going to introduce the mathematics behind how those inverses work until much later in the course. So just kind of keep in mind that the calculator can do it if you have to for some reason, but most of the time we're going to be doing manual calculations to find exact answers, not approximations. That's why this video lecture is so short.